Okay, let's take a look at this example. We will make use of some properties that we've learned to solve this question. All right. Let's see the identity you're supposed to show. Let's deal with this expression first. I'm going to slowly prove that this left hand side is equals to the right hand side. So let's do one by one. Let's deal with this, the mod u plus v mod square. Now the first thing I'm going to say is this. You should be familiar. Recall that u dot u equals to mod u square. I'm not going to prove it. Yes, you go back to your notes. It's not difficult to prove, which means you can go one way. You can go this way. You can also go the other way, mod u square. Correct? So now I have this vector, which is u plus v mod square, is actually u dot v dot u dot v. All right? Dot u dot v. So a vector dot itself is actually mod u square. All right. So that's that. The next thing, if you can see this expression here, you would not difficult to come to your mind the distributive property. All right, the distributive property of dot product or scalar product over addition, which is this property over here, which if you can see the proof is above here. So we can distribute it across like that. And then if you can see these two expressions, these two dot product is commutative. So u dot v is the same as v dot u. So it's equals to 2 times of u dot v. Now again, I will use, after this step, I will use this idea one more time. All right, this idea one more time on here, on these two expressions, okay, to get the u mod u square mod v square like that. At first glance, this may not be very useful, but if you apply exactly the same thing onto this expression here, then you can see that the expression, I'm not going to repeat, you will see the same things here, 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 here. And if you add them together, you will realize that these two terms cancels off because there's a plus and a minus. I'm going to show it here. And then you realize that if you add these two together, these two terms cancels off. And then you get the final result. Yeah, so here illustrates. I just want to emphasize that it is quite useful. These two results listed here have been very useful in solving this example.